Number 4 is tricky. So remember that whenever we are using, we're using the idea of SSA, so side angle, that we have 3 options. One is there's no triangle, or if there does exist an answer, it's either going to produce a 1 triangle or a second triangle. So potentially we have the option of having 3 angles and their sides across from them, and that would be 1 triangle, and then we have another option. Now we're going to talk about why is that in just a second. So let's get started. I can see I have side, angle. And so again, gives us our opportunity. And so I'm going to get this set up. We're going to do the sine of 30 degrees over 8. So these are opposite, is equal to the sine of b over 15. I'm going to cross multiply here. So I have sine of 30 degrees over 8 equals the sine of b. I kind of skipped one step there. It would have been set equal to 8 times the sine of b, and then I divide by 8. So I kind of did one step in here. So this is the first thing. This will tell me if this even exists. Remember, SSA can produce no triangle, 1 triangle, or 2 triangles. Excuse me. 15 sine of 30, and then divide by 8. What does this tell me? I know this tells me that at least 1 triangle exists, potentially 2. Why? Because this sine equals a value. It equals a value, and this value is between -1 to 1. And so if it's in that range, I know it exists. Now, here's the problem. Sine can't distinguish between an acute angle, which would be an angle measurement less than 90, or an obtuse angle, which is greater than 90. So let me demonstrate. I'm going to go second sine, so that'd be the arc sine, also known as inverse sine, and then I'm going to copy and paste this in. All right, so sine tells me we have 69.64 degrees. This is an acute angle. So we're going to go ahead, and if I could draw this somewhat to scale, let's look at this. All right, so this would be, let's think here, if this is 90, there's 45, 30 is somewhere like that, that's A. And then, so if this is 90, and this is 45, 69 is somewhere like right here. Okay, this is going to be angle B, and so this angle is 69.64 degrees. This angle is 30 degrees as given information, and this is angle C. So let's do this first triangle. A, B, C, little a, little b, and little c. Okay, we know that this is 30 degrees. Now I had to round for B, and so it's 69.64. How can I figure that missing side? Again, we know that the interior angles of a triangle add up to 180, so let's subtract 30 and subtract the rounded 69.64, and we end up with 80.36. 80.36 degrees. Okay, got those. We know that we're given that opposite of B is going to be 15 units and opposite of A is going to be 8 units. And I want to stress, as I've done in previous videos, we cannot use the Pythagorean theorem to find a missing side because it's not a right triangle. So when you're thinking, how am I going to use the law of sine to do this? We always want to use an angles that we have not rounded. Like this is rounded, so we're going to use this one. Sine of 30 degrees over 8 equals the sine of 80.36 degrees over C. And I'm going to cross multiply here. So I have C times the sine of 30 degrees equals 8 times the sine of 80.36. Let's divide by the sine of 30. Divide by the sine of 30. I'm going to push this up in just a second. All right, let's grab this right now so we can see this. We have 8 times the sine of 80.36, get an answer, and then divided by the sine of 30. All right, so I believe that this is approximately 15.77. This is one triangle. That is the case. This is an acute. This is acute. Now, let me push this up, and then let's talk about what if it was an obtuse angle. So the first thing to do is I want you just to think of this right now. If we had a reference angle of 69.64, 69.64 would be right here, right? And so if I asked where is a sine value equivalent to this? Well, I know it's a positive value for sine. Where in what other quadrant, 2, 3, or 4, do I find a positive sine? That'd be right here. So I want to know what is this measurement? From here to here, what is this measurement? So my reference angle of 69.64 helps me. I'm going to take 180 and I'm going to subtract 69.64. 180 subtract 69.64 gives me 110.06. So let's do this. A, B, C, little a, little b, and little c. Now I'm going to draw this as close as possible. Okay, so here we go. The more accurate we can draw this, the better we'll have. So 30 degrees, let's see, if here's 90, there's 90, there's 45. 30 degrees is something like this. That's 30. Okay, now I want to do 110, right? We know that this is 110. So there's 90. And so past 90, I need to do another 20. So something like that. There's 90 past that. And I'm just going to keep going until they connect. There we go. There's my B, and there's my C. Okay, so A is equal to 30 degrees. We know B is approximately 110.69. And I can find C by going 30 plus 110.69, taking it and subtracting 180 from that amount. And so I get 39.04. 39.04. Okay, now what else do we know? If we go back to this original problem said across from angle A was 8. Across from angle A was side. That was exactly 8. And across from B was 15. Now we just need to find C. And again, you were maybe wondering, like, do I use A or do I use B with the loss sign? Well, I can see that I had to estimate here and I had to estimate here, so I just stick with A. Sine of A, which is 30 degrees, over side A, which is 8, equals sine of C over little c. Cross multiplying, C times the sine of 30 equals 8 times the sine of 39.04. Divide by the sine of 30. Divide by the sine of 30. Okay, let's plug it in. Here we go. 8 times the sine of 39.04. We're going to get an answer. And then I'm going to divide by the sine of 30. We're make sure you're in degrees. And so I can see that side C is approximately 10.08. But let's go back here and let's think of this. The smallest angle has to have the smallest measurement directly across from it. So this is the smallest angle, smallest side. This is the largest and the longest side. Makes sense. So I have two unique triangles given the following information.